In this video, we are going to take a look at some of the enhancements that we have made in the relational model, more specifically in how we can specify table relations. To start, I'm going to show the simple example of two tables. This is the teacher table and the course table. The teacher table has a bunch of fields like name, age, and address. The name is also an alternate key, as we can see over here. There's an index defined on name. The course table has a bunch of simple fields like course ID, level, and name. Right now, I have no relations defined between these two tables. So let's create a relation between the course and the teacher. I'm going to call this relation teacher, and the table that it is related to is the teacher table. Next, we are going to define how these two tables are related. So what you will notice now is that in addition to all the types of relations that were present in AX 2009, we also have this new foreign key relations. There are two types of foreign key relations that can be defined. The first one is the primary key based. If we choose this, these two tables will be related by the primary key of teacher. There's also another type of foreign key relation that can be specified. If we specify the single field alternate key based relation, we can pick an alternate key from the teacher table and define the relation based on the field in that. Note that the alternate key index from the teacher table needs to have a single field. So if we choose the primary key based, what you will notice is that it created the teacher field over here in course, and then it also defined this relation based on the rec ID of the teacher, which happens to be the primary key of the teacher. On the contrary, if we would have defined this relation based on the single field alternate key, it would have done it slightly in a different way. See, if we do the single field alternate key way, the relation is defined on the name field in the teacher. What you will also notice in AX 2012 is that the relation has a bunch of new properties. Next, we are going to take a look at what these properties mean and how we can define them. The first set of properties that we are going to take a look at are cardinality and related table cardinality. Notice that the relation is defined on the course table. Course table is the table that holds the foreign key. In our conceptual model, one teacher can teach many courses. However, a course must have exactly one teacher. The cardinality on the side of the course is defined by the cardinality property in the AOT. The cardinality on the teacher side is defined with related table cardinality property in the AOT. There are several values for cardinality. These express 0 or 1, exactly 1, 0 or more, or 1 or more. On the related table cardinality side, the options are 0 or 1 and exactly 1. In our case, a teacher can teach 0 or more courses. Therefore, the value we will choose is 0 or more. On the teacher side, a course must have exactly one teacher. A course cannot exist with no teacher assigned. Therefore, we are going to set exactly one. Based on the model that you have, you can pick the right values for the cardinality and the related table cardinality properties. The next property that we are going to take a look at is the relationship type. There are these 5 different values that can be set for the relationship type property. We are going to take a look at association, aggregation, and composition in more detail in a little bit. When two tables participate in an inheritance hierarchy, then on the child table or the derived table, the relationship type is specialization. Link is how we specify self relations. When there is no link between the lifetime of two entities that are participating in the relationship type can be said as association. This is the most common type of relation. In this example, a teacher is associated with a student with a many-to-many relation. A teacher can have many students, a student can have many teachers. Deleting of one entity has no impact on the lifetime of the other entity. This type of relation is specified by choosing association. The next type of relation is called aggregation. In this type of relation, the child objects cannot belong to another parent. So, this can be thought of as a has a relation. So, we can say a course has a teacher. Deletion of a teacher does not necessarily destroy all of the course entities. This type of relation is called aggregation. And finally, when there is a strong link between the lifetime of two entities, then that type of relation can be thought of as composition. In this example, a house can have many rooms. However, deletion of a house automatically implies that all associated rooms need to be deleted from the system. This type of relation can be modeled by choosing composition in the property. The next properties that we are going to look at are related table role and role. The role and the related table role properties specify the functions or roles played by the two tables in the relationship. This information is not in the physical data model, and based on how these are to be viewed conceptually, the names should be chosen. If use default role names property is set to yes, the system will generate the related table role and role based on the name of the relation. If we'd like to override these, we can also type the names of the related table role and role in the AOT. In this case, I am going to set the role as course, which is the same as the name of the table, and related table role I am going to set as teacher of. This is how we can choose meaningful names for related table role and role. The next two properties that we are going to discuss are called create navigation property methods and navigation property method name override. When the create navigation property method property is set to yes, the system will create a navigation property on the X++ entity corresponding to course. This navigation property will help us navigate this relation and associate a course with its teacher. By default, the system picks the related table role as the name of the navigation property. This can also be overridden by setting a custom name in the navigation property method name override. These two properties are used by the unit of work framework to relate the associated table buffers. To summarize this video, we have taken a look at how foreign key relations can be created on tables, and also looked at some of the new properties in the table relation metadata. These properties have no impact on runtime. However, they can be used to reverse engineer the conceptual model from Dynamics AX entities.